Today we are going to talk about the Orgel diagrams. So Orgel diagrams are nothing but a plot between term symbol and delta naught. Okay, if we want to plot perfect Orgel diagram, first we have to know the d orbital splitting and f orbital splitting and third one is electron promotion, hole inversion. So these are very important to draw the Orgel diagrams. Okay, so we know that first we'll go for d orbital splitting. So there are two kinds of d orbital splitting, similar to octahedral field, and second one is opposite to octahedral field. Similar to octahedral field means this is D split into T to Z will be the ground state term and EG will be higher energy state. So this is similar to octahedral field, and opposite to octahedral field means it's just opposite. EG comes down and T to G comes up. So these are the this is the way how d orbital will split. So in octahedral field it splits into T2G and EG, and T2G is the lower energy state and EG is the higher energy state. Where opposite to octahedral field it splits into EG will be the ground state and T2G will be the higher energy state. And similarly f orbital splitting also two types. Here first we will see how it split in octahedral field. We can say similar to octahedral field and opposite to octahedral field. So f orbital splits into three terms. So this is the energy barrier. So lower energy state will be A to G, T2G and T1G. So this is the similar to octahedral field. Whereas in opposite to octahedral field, these two goes up and T1G comes down. So T1G, A2G and T2G. Okay, so this is the similar to octahedral field and this is the opposite to octahedral field. And the energy states, the energy of each term is very important. While calculating the CFSC value, these energies are very important. This energy is 12 dQ, this is minus 2 dQ, this is plus 6 dQ, and similarly here is a minus 6 dQ, this is a 2 dQ, and this is a plus 2 dQ, this is plus 12 dQ. Sorry, this is A to G, this is T to G. So this is A to G and this is T to G, and the energies will be, this is plus 12 dQ, and this is plus 2 dQ. So this is the similar to octahedral field and this is opposite to octahedral field. So now we have seen d orbital splitting and f orbital splitting. Now we see the electron promotion, hole inversion. These two are very important. So if we know these two things, it's very easy to predict which is a ground state in the Orgel diagram and which is the excited state, means higher energy state. So electron promotion means we'll take a d1 configuration. Okay, so we have a Eg and T2g. This is T2g and this is Eg. If we'll give some energy, this electron goes from here to here. Now it becomes like this, and after this electron left this orbital, here a hole is created, empty orbital is created, right? So to identify whether this is the electron promotion or hole inversion, a simple indication is wherever hole is forming, that has to be accompanied by another empty orbital. So this is the empty orbital here formed, and this has to be accompanied by another empty orbital. Here instead of 1, 2 are there, 1 is sufficient. So here we got empty orbital, and here also empty orbital is there. So this is a electron promotion. And for D2, we'll take D2 now. One, two. So this electron goes from here to here. Then it becomes like this, and here empty orbital is formed. So that empty orbital is accompanied by another empty orbital, right? So this also comes under electron promotion. Now we'll go for the D3. Now it will be clear. We have 1, 2, 3 orbitals in T2g. So now one electron goes from here to here. So now here hole is created, but this hole or empty orbital is not accompanied by another empty orbital in the T2g level. So this kind of complexes comes under hole inversion. Okay, so D1 comes under electron promotion, D2 comes under electron promotion, but D3 comes under hole inversion, because in case of D1, when electron jumps from this T2g orbital to Eg orbital, here hole is created. So that hole is accompanied by another hole, and similarly in D2 also, here accompanied by two holes are there. Here in D2 orbital, electron went from here to here, so hole is created. That hole also having another hole is there in T2g orbital. Because of that, it is electron promotion. Whereas in D3, there is only one hole. This is not having any another hole or empty orbital. Because of that, this is a hole inversion. Now we'll go for the D4. So we have to fill 4 electrons. 1, 2, 3. So Orgel diagram is only for high spin complexes, not for the low spin complexes. So 4th electron goes here, and when the electron shifts from here to here, it can be here or here. Imagine it went here. So here one empty orbital is formed, but this empty orbital is not having same orbital in the T2g orbital. So because of that, this also comes under hole inversion. And D5 we will not talk about Orgel diagram. So now we'll go for the D6. One, two, three, 4, 5, 6. So this electron will go from here to here. If in one orbital 2 electrons are there, in another orbital 1 electron is there, means where two electrons are there, that electron will goes to Eg orbitals. Now see, here hole is created. So this empty orbital is having 1 electron in its orbital. That means there should be another orbital which is having 1 electron in its orbital. That means here one electron is there, and here also 1 electron is there, here also 1 electron is there. So this comes at electron promotion. So in case of D1, D2, D3, we talk about the complete empty orbital. But whereas in case of D6, we are talking about the half-filled empty orbital. So here after electron went from T to G to EG orbital, here single electron having orbital is there, right? So one more orbital, same orbital has to be there in T to G orbital, so that comes under electron promotion. Here we have one electron which is having a, here we have this orbital which is having one electron, and this also have one electron, and this is also having one electron, so one is sufficient, so this comes under electron promotion. And we'll go for D7. One, two, three, 4, 5, 6, 7. So this electron goes from here to here. Now here, see, here empty orbital is forming, means off-filled empty orbital. So there should be same orbital, another orbital, same, there should be one more same orbital. So this is same and this is same, so this also comes under electron promotion. Now we'll go for D8. One, two, three, 4, 5, 6, 7, 8. Now here also one electron goes from T to G to EG. So now see, here empty orbital is formed. Same orbital is not there in T to G, because only one orbital is having single electron, remaining two orbitals having 2 electron. So this comes under hole inversion. Next we have D9. This is the last one. One, two, three, 4, 5, 6, 7, 8, 9. So this electron goes from here to here. And here see, so here one orbital is with a single electron, okay, but no, remaining two are having two orbitals, so same orbital is not there in T to G orbital, so this comes under hole inversion. Okay, this is a little we have to understand good, otherwise difficult. So in case of D1 orbital, one electron is there in T to G. If we will give some energy, that electron go from the T to G to EG orbital. Okay, after this electron left from here to here, there is an empty orbital. Empty orbital is forming, and in the T to G orbital, same orbital has to be there. Means this is empty, so another orbital has to be empty. Then only it comes under electron promotion. If the same orbital is not that empty orbital, then that comes under a hole inversion. So here it's a empty orbital, and here also empty orbital, empty orbital. So this comes under electron promotion. One is sufficient. And then we have a D2. Here in D2 also this electron went from here to here, and here empty orbital is formed, and here one electron is there, but here empty orbital is there, and these two are same. So this comes under electron promotion. And in case of D3, here we can see here empty orbital is forming, but other orbitals are not empty. They are having single orbital, and these two are different from this orbital. So that's why it comes under hole inversion. Two same orbital has to be there, then it comes under electron promotion. If different orbitals are there, then it comes under hole inversion. And similarly, in case of D4 also, the electron is going from here to here. Empty orbital is forming here, so remaining orbitals are not having a same orbital, so this comes under hole inversion. And D6, and electron going from here to here, so this is the reference for us. So this is having a single electron, and there should be another orbital having a single electron. Instead of one, here two orbital having single electrons. This comes under electron promotion. And similarly for D8, so this electron going from here to here, so here single electron is generating, but other orbitals having two orbitals, so same orbital is not there, so it comes in hole inversion. So this is about the electron promotion and hole inversion. And now complexes which shows electron promotion, they shows different kind of d orbital splitting. Like we have a electron promotion, complexes which shows electron promotion, and complexes which shows hole inversion. So complexes which shows electron promotion, in that d orbital splitting will be similar to octahedral, means this is T2G and this is EG. And compounds which shows hole inversion, in that d orbital splitting will be opposite. That means EG comes here and T2G comes here. Okay, this is about the D term. And now we will go for the F term. So it's just opposite to D term. So here similar, I said here similar, so just keep opposite here. Opposite to octahedral field, that means this is T1G, this is T2G, this is A2G. And for hole inversion, F term will be similar to octahedral. That means this is A2G, T2G, T1G. Okay, so this, if you can remember this one, it's very easy to plot Orgel diagrams. It's very simple. For complexes which shows electron promotion like D1, D2, D6, D7, this shows electron promotion, and D3, D4, D8, D9, this shows hole inversion. So for complexes which shows electron promotion, you can see the Orgel diagram like this. Imagine that for D2 will take, so in case of D2, ground state term will be 3F. So splitting will be like this. This is T1G, T2G, A2G, and it is 3P will come here. This will be 3 T1G. So Orgel diagram will looks like this. So we just need to remember these points. Where electron promotion is there, they are similar to octahedral, and F orbital will be opposite to octahedral. Where hole inversion is there, they are opposite to d orbital will be opposite, and F orbital will be similar. So here D1, D4, D6 and D9, these complexes shows ground state term will be D. Whereas for D2, D7, D3, D8, this will shows ground state term will be F term. So now we will see how Orgel diagram will plot for these 8 metal complexes. First we will take a D1. So here one electron is there, so ms values will be -2, -1, 0, +1 and +2. Here L equals to 2. Then S will be 2s plus 1, that is 2 into 1 by 2 plus 1, that will be 2. And J will be start from L plus S to L minus S. For if it is a less than half fill, L minus S will be J value. If it is more than half fill, L plus S will be J value. So here the term will be D, because L is 2, so term will be D, and 2 D. So since it is a less than half fill, so J value will be 2 minus 1 by 2. This will be 3 by 2. This is the ground state term for the D1. Now we will see the splitting. So this will be 2D. So D1 comes under electron promotion, right? If it's electron promotion, means similar to octahedral field. That means this will be T2G, this will be EG. This is for the D1. So here only one transition is possible. Okay, this is for D1. This is the Orgel diagram for D1. This will be delta naught. And now we'll go for the D9 or D6. Okay, so just remember D1 and D6 both are same. Okay, and D4, D9 is same. Same means this splitting is same, but spin value will change. I think spin value will change. So now we'll see D6. Because D1 and D6 both shows electron promotion, and D4, D9 shows hole inversion. So because of that one, their Orgel diagram is same, but spin will change. 1 2 3 4 5 6 minus 2 plus 2 minus 1 0 plus 1 plus 2. This will get cancelled, this get cancelled. So L value is 2 here, and S value will be 1 2 3 4. 4 means 4 halves are 2. Spin value will be 2 into 2 plus 1. This is 5. So here term will be 5d. Okay, and this will be 5d. So since it is electron from motion, so this will be 5t2g, this will be 5eg. So this is Orgel diagram for d6. Splitting will be same in case of d1 and d6, only spin value will change. And for d4 and d9, we have a d4 here, and here d6, it's more than half filled, right? So J value will be L plus S. L value how much? 2. S value how much? 2. So 4. So this is the ground state term. And d4, 1 2 3 4, minus 2 minus 1 0 plus 1 plus 1 minus 1 will get cancelled. So now only L left is 2. L is 2, that means term will be D, and S will be how much? 2. 2 into 2 plus 1 equals to 5D. So this will be a ground state term will be 5D. And since D4 involves in hole inversion, so this follows opposite to the octahedral field splitting. That means EG comes down and T2G comes up. And here we also need to remember that in the D4 configuration, 1 2 3 4, so here we can see T2G is a symmetric, and but EG is unsymmetric. So because of that, EG orbital further splits. Okay, so here EG is having a unsymmetry in nature. So because of that reason, EG further splits into two energy states. This will be dx square minus y square, and this will be dz square. So here we have two transitions. One is transition from here, another transition will be from here to here. So there are we have to remember the Mulliken symbols also for dx square minus y square, dz square, dxy, dyz, dzx. So the Mulliken symbol for this one will be EG, and dz square will be A1G, this will be B1G, and this will be P2G. So these are the Mulliken symbols for these energy states. So when we have a D4 configuration, so this is EG and this is T2G. So since T2G is unsymmetrically filled, so further this will split into two energy terms, dx square minus y square. The Mulliken symbol of this one will be B1G, and dz square, the Mulliken symbol of this one will be A1G, and this will be T2G. So there are two transitions from here to here, one transition, this is another transition. So in the Orgel diagram we will get a two line for this D4 configuration. And similarly D9 also. In the D9 we have a unsymmetrically filled T2G, symmetrically filled EG. So here it's highly unsymmetric, right? So and in case of D9 configuration, we see mostly in case of D9 we will see Jandal distortion also. So this will be EG, this will be T2G. So because of its highly unsymmetric in nature, in case of D4 we see only splitting of only EG term, but This also splits, T2G also splits into two energy states, like T2G also splits into like this, dxy dyz as well as dxy. This is dx, wait dxy dyz zx. But the energy gap between these two levels are very small. That means you can neglect it. That's why I'm not showing here any two energy states. Here it will be, we can neglect that much distance will be there. But whereas in case of D9, there will be strong splitting of these terms also. Okay, so this will be dx square minus y square dz square dxy dyz dz. So for D9, this is a 2D term, is 2D. So because of unsymmetry in EG orbital, this both the terms T2G as well as EG further splits into dx square minus y square and dz square and dxy dyz dzx. And we can write a Mulliken symbols for these things. So dx square minus y square Mulliken symbol will be b1g, and for dz square this is a1g, dxy this is b2g, and this is a eg. Okay, so in examination point of view, they may ask what is the ground state term symbol for D9 configuration. So a ground state term symbol will be b1g. They will not ask dx square minus y square dz square. Okay, ground term state symbol will be b1g. And similarly for D4 also, the ground state term symbol will be b1g. So here we will get a transitions 1, like that we will get 4 transitions.